हेलो स्टूडेंट्स, आज का हमारा टॉपिक है डिबाई सैचर मेथड और पाउडर मेथड. Liu method and rotating crystal method can be applied only if single crystals of reasonable size are available. However, most of the crystalline substances naturally available are in the form of polycrystals. The method of preparation of single crystal is quite difficult. Debye and scherrer method provides the details about the crystal structure even if the specimen taken for investigation is in the form of polycrystals. The crystalline substance is be finely grounded and powered so that its tiny crystals are randomly oriented. Powder specimens see stuck on here by means of gum and placed in the path of a narrow monochromatic X-ray as shown in Fig 1.52a. Basic principle of this method is that millions of tiny crystals in the powder are randomly oriented. All possible diffraction planes will be available for Bragg reflection. Such reflection will take place from many sets of parallel planes lying at different angles to the incident X-ray beam. Moreover, each set will give not only first-order reflection but those of higher orders as well. Since all orientations are equal, likely the reflective rays will form a cone whose axes lie along the direction of incident beam and whose semi-vertical angle is twice the glancing angle for that particular set of planes, which is shown in Fig 1.52b. For each set of planes and for each order, there will be such cone-reflected X-rays. Their interactions with a photographic film form a series of concentric circular rings. Radio of these rings are recorded and the film can be used to find the glancing angle and hence interplanar spacing of crystalline substances. नेक्स्ट है हमारे पास experimental arrangement. The rays from the tube are passed through filter F. It gives out monochromatic X-rays collimated by two point slates S1 and S2. Then X-rays beam falls on the powder specimen C stuck on here by means of gum as shown in Fig 1.53a and suspended along the axis of cylindrical camera called Debye scherrer camera. The photographic film is mounted around the inner surface of camera and almost completely surrounds C in order to receive X-rays diffracted up to 180 degrees. Since the film is of narrow width, only parts of the circular rings register on the film as shown in Fig 1.53b. The curvature of these arcs reverses after the angle of diffraction exceeds 90 degrees. If the distance between symmetrical lines on the stretched photograph are L1, L2, L3 up to so on and diameter of the cylindrical film is d, then next है हमारे पास equation L1 divided by pi d is equal to 4 theta 1 divided by 360 degree. थीटा 1 है हमारे पास इज इक्वल टू 90 डिग्री ओवर पाई डी L1. थीटा 1 इज इक्वल टू के L1. के हमारे पास है 90 डिग्री डिवाइडेड बाय पाई डी. सो जो के L1 हो गया हमारे पास इज इक्वल टू थीटा 1. Similarly, theta 2 is equal to k L2 and theta 3 is equal to k L3. Using these values of theta in Bragg's formula, interplanar spacing d can be calculated as follows. We have 2 d sin theta is equal to n lambda where n is constant. Differentiating, we get 2 del d sin theta plus 2 d sin theta del theta is equal to 0. Shown case using product rule, which is d over dx ab is equal to a, d over dx b plus b d over dx a. हमने प्रोडक्ट रूल यूज़ किया है 2d cos theta del theta is equal to minus 2 del d sin theta. del थीटा में आके डिवाइड हो जाएगा नीचे del थीटा ओवर del d इज इक्वल टू माइनस साइन थीटा ओवर cos थीटा 1 बाई d. del थीटा ओवर del d इज इक्वल टू माइनस टेन थीटा ओवर d, क्योंकि साइन थीटा डिवाइडेड बाई cos थीटा होता है हमारे पास टेन थीटा. The radius del theta over del d will be maximum when theta is equal to 90 degree or 2 theta is equal to 180 degree. This means X-rays are reflected back along initial path. This is known as a back reflection. Such back reflections cannot be recorded experimentally. Hence, del theta over del d should be large. The advantage of this method is that it does not record large single crystals and almost any substance can be grounded into powder. By measuring the distance between symmetrical lines and lines intensities, following information can be obtained. Number 1. A crystalline substance can be distinguished from an amorphous one because crystalline substance produces lines on a photograph while amorphous does not. Number 2. If photographs are made before and after thermal or mechanical treatment of a crystalline substance, their comparison can reveal any alteration in the lattice. Number 3. With the aid of standard photographs of known chemical of compounds, their presence may be detected in an unknown mixture. And हमारे पास last है, the size of unit cell and the type of lattice can be determined in simple cases. The powder method has been employed in the study of microscopic substances like metals, alloys, carbon, fluorescent powders, and other forms where single crystals are not available. नेक्स्ट हम पढ़ेंगे अपनी अगली वीडियो में इंशाल्लाह.